This is Derek, and in this section we're going to look at sequences. If you're in the co-rec, this is chapter 12, and in 141, chapter 8. So first off, definition of a sequence. A sequence is a function f of n whose domain is the set of all non-negative integers. So that's where this is a little bit different from what we've been doing. So non-negative integers are numbers like 1, 2, 3, 4, etc. So when we have this function, we're not going to put in fractional values, like there are no 1.5s, there's no values in between. It's just going to be these numbers. So what we're going to get out is a set of numbers or a list of numbers, and that's going to be a sequence. The notation's a little bit different on these. So we're used to saying if we're trying to evaluate a function at 1, we would call that f of 1. And what we're going to get out now, instead of just y values, we're going to call them terms instead of just the outputs. They're going to have the specific name. And instead of using f of 1, we're going to do this a sub n thing. So the first term would be a sub 1. The second term would be a sub 2. So this is a way to indicate where in that list of numbers that value is. And it's the same thing as f of n. It's accomplishing the same thing, but this a sub n is going to be our notation for sequences. And then in terms of sequences, we're going to see two flavors: arithmetic, which is the first one we'll look at down here, and then also geometric. So starting with arithmetic, this is basically like a linear equation. An arithmetic sequence is a sequence that has the property that the difference between any two consecutive terms is constant. In other words, the rate of change between two terms is constant, so it's just like having a linear equation of constant slope, except that we don't get all the in-between numbers, which I'll show you here in just a second. And then this constant is called the common difference, and it's going to be labeled D. Here's where we see that nth term idea, where we're having terms instead of outputs. So we're going to have nth term formulas. So these are the formulas that will give us any term of the sequence, and we'll see this is going to be our one for arithmetic, and we'll have another one coming up for geometric. But a sub n, so this whatever term we're looking for, the 37th term of this thing, whatever value that is going to be a sub 1, our first term, or our starting value, plus d, and that's going to be that common difference. It's like our slope, it's how much it's changing by, times n minus 1. And so I just set up a really simple example over here, where I put in, let's say our starting value, this a sub 1, is going to be this 3, and then our common difference is going to be 2. So this would be something that was starting on 3 and then going up by 2, and I made a table of the same thing. So if I was here, if I was thinking of this as a line, I get all of these points in between, because in this function, I can put 1.5, 1.7, 1.8, whatever. I get all these values in between the points. But if I'm thinking of this as a sequence, then I can't, it's not going to fill in everywhere. It won't have that. It would just be these dots that you're seeing. Our first value would be 3. When I put a 1 into this, there's our 1 minus 1 makes 0, 2 times 0 makes 3, so our first term would be 3. When I put a 2 into this, 2 minus 1 would be 1 times 2, would be 2 plus 3 makes that 5. So you can see I'm starting here on 3, and then I'm counting up by 2s. And so those little orange dots, that would represent a sequence versus this blue line, which would be a linear equation where I don't have that restriction on x. So that's kind of the difference between, is this a line? Sort of. It's these individual points on the line, which we then end up writing as these lists that we call sequences. Okay, so let me put that away. So first question is the sequence arithmetic? If so, what's the common difference? So here's an example of a sequence. Again, list of numbers. And here 2 to 5, so that's increasing by 3. The difference between 5 and 8, still increasing by 3. 8 to 11, increasing by 3. So that's what we mean by common difference. This one, its first term started on 2, and then from there on, it's counting up by 3. So 5, 8, 11 are next to be 14, 17, etc. So this we would say, yes, it does have a common difference of 3. Looking at this next example, the first difference is 2, but then the next difference is 4. So you can see the there isn't a common difference. The difference between the terms is increasing each time. So no, this is not arithmetic. Okay, so this next example is asking us to find the seventh term if the first term is 13 and the common difference is 5. So they're giving us a lot of pieces of the nth term formula here. So what I like to do is I just kind of start a list of what I know. I know I'm looking for the seventh term, so that means my n is 7, right? Because that's what that is. There's our nth term, or n is 7. Our first term is 13, that's our a sub 1, and our common difference is 5, so d is 5. And anytime we're looking for a term, this is the formula we got. And you'll see the same thing when we do geometric. There's just one formula for it, so if we're trying to find a term, you just have to figure out, is it geometric or arithmetic? So here's our formula. We know we're looking for the seventh term, and that's what this side of the formula is, a sub n, so we're looking for the seventh term. The first term we know is 13, d, they told us is 5, and we know we're looking for n is 7, that's right there, and then that fills in the right-hand side. 7 minus 1 made 6 times 5 for 30, and then that makes our seventh term 43. Number 3 here, write an explicit formula. So now we're kind of trying to get something that is more like this right here for the following arithmetic sequence that starts at a sub 1. So we're given 30, 22, 14, and then we have to kind of deduce what we can from that information. So we know the first term right here is 30, so I wrote that one down. The difference, notice this time it's counting down by 8, so I want to be careful that I get that negative 8 on there, because we're starting at 30, and then this would make the next one 22, down from there would be 14. And then filling in what I know, we're just trying to find the formula in this case, so we're not trying to find a specific n, just a formula to generate any given n's. So this would be 30 for my first term, my difference of negative 8, and then all I'm doing here is cleaning this up a little bit to make it tidier. So distributing there, and then negative and negative for positive, and then combining my like terms. So this would be my nth term formula for that sequence. And if you want to try it out, if you put in when n is 1, 38 minus 8 would give us 30. When n is 2, 38 minus 16, there's the 22. So all this is a formula that given, n is 1, 2, 3, 4, 5, 6, whatever, we can generate this list. For number 4 here, we have find the number of terms in the given arithmetic sequence. So find the number of terms. That means we're solving for n. So I have n as my question mark down here. And here's the information they gave me. My first term is going to be 3, and then it goes from 3 to 1, so we're counting down by 2, so again, we got to be careful on the negative there. And we don't know which term this is, but it's the one that's corresponding to this n we're trying to find. This is our nth term. We're just trying to figure out what n would make it come out to negative 35. But what that means is this side of the equation is that negative 35, and now we're solving for n. And so if you notice, I just keep coming back to, actually bring it over here, what do I know, what am I trying to find? There's 4 values here, and you generally are going to have 3 of them, and from that you can get the rest. So, and they'll actually get a little bit trickier on this next one, but that is the general idea. So then all I'm doing is plugging into my formula, so my nth term is there, there's my starting value, my difference, and then I just go through and I solve for this n. So negative 2n and negative made that 2, 2 and 3 for the 5, subtracted the 5 over for that 40 right there, and then divide. So that means if I put n equals 20 into that formula, then I should get that negative 35, or that is the 20th term. For this one, we were asked to find the 5th term if the first term is 47 and the 9th term is negative 17. So back here, I need, in order to find a given term, which is what we're being asked to find the 5th term, I need the first term, I need the difference, and then I need which term I'm looking for. So I know I know the first term, and then I do not know d, but I do know that when n is 9, that output is 17. So what I can do here is say the output is going to be 17, 47 is my first term. D is what I don't know yet, so I could solve for that d by using this term because they gave me essentially an ordered pair. They gave me when n is 9, that output is 17, so I can just put my n is 9 in right there, 9 minus 1 for 8, and divide it over, and now I have my, my difference. And this one works, this one's a little bit easier than the next one coming up, and it's because here they gave me the first term. Here, notice they didn't give me the first term, so I'm going to have to get a little more heroic on this one. But once I have this difference, great, now I can find my fifth term, so I'm just saying I'm going to find the fifth term. Plugging in, I have 47, there's my difference now, and I know I'm doing the fifth term, so 5 minus 1 for 4, do the math and get the fifth term is 15. And you might look at this and go, like, can I count up? And you couldn't, not until you found that difference. So that's the piece that you actually needed to do this. Here we have something similar. Find the first term, or a sub 1, of an arithmetic sequence if a sub 8 is 88 and a sub 14 is 154. So it looks like this one in that they gave us these 2 points, but notice here they gave us the first term, and then here they did not give us the first term. So this one's going to suck a little extra. What we can do, and remember when I had the graph up, these are, it's like a line, but it's individual points in a line. But we can still find the slope of those individual points the same way we did when we were doing linear equations. So here, when the number changes from 8 to 14, the input, the n changes from 8 to 14, then the output changes from 88 to 154. So all I'm doing is slope. My change in my output is 154 minus 88. My change in my input is 14 minus 8. So it's just change in y over change in x again. And then doing that little bit of math, then that gets me my common difference. And in this case was 11. Once I have that, now I'm in better shape. I'm asked to find the first term this time. And so that was this piece of the formula, right? So when we have an nth term, our first term is here. And if I know an n, then I can fill that in here if I know the term that goes with it. And I have a couple of those in this that I can use. So I'm going to use my 8th term just because the numbers are smaller. So I'm going to do the 8th term equals the first term plus the difference, 8 minus 1, and then filling what I know. My 8th term was 88, so I'm just showing I'm putting that in the y side. I don't know this first term. My difference we found right there was 11, and then 8 minus 1 for 7. From there, 77, scooted over, and then we got our first term. But so notice everything in this first half of the section, it really does kind of come back to that formula, with this one exception here where we have to be a little bit sneaky and realize we're essentially just finding the rate of change, which is slope. And since this is a constant rate of change, this constant difference, we can just treat it like slope. Next up for this section is going to be geometric sequences. So these ones were linear. These ones are going to be exponentials. And so for the nth term formula for a geometric sequence, that's going to be given by this. Let me zoom in on that for a second. So it goes a sub n equals a sub 1. Now we're going to have this common ratio to the n minus 1. So that's what we're going to keep going back to every time we're trying to do a geometric sequence in terms of finding the terms. So a sub 1 is the first term. R is called this fixed ratio or common ratio, depending on which book you're looking at. And I'll show you what that looks like down here for this example. So determine if the sequence is geometric. If so, find the common ratio. So these are the same 2 examples I had up for that first example. So now if I tried to do the ratio of consecutive terms, which is what this is saying, 5 over 2, and then when I try to do the ratio of the next 2 terms, 8 over 5, 5 halves does not equal 8 fifths, so there is no common ratio between the terms. But if I go over to this one, remember how this failed? It was 2 and then 4 and then 8, so it didn't have a common difference. But if I find the ratio of the second to the first term, 4 over 2 would be 2, and the ratio of the third to the second term, 8 over 4 is still 2. The ratio of the fourth and third term, 16 over 8, is still 2. So that's what it looks like with a common ratio, and there's that kind of exponential growth versus linear. And so this one would say, yes, it is a geometric sequence and its ratio is 2. After that, it's very similar style problems, but with this other form, where now we have geometric sequences instead of arithmetic sequences. So write the first 5 terms of the geometric sequence given the first term and the common ratio. Answer exactly. Okay, so here's my nth term formula. So I'm just plugging in here for my first term and my ratio. That's what we're doing on these ones. They gave us the first term is 3 and the ratio was 1/3. And then there's a little n minus 1. And then after this, I'm just going to grind out like a bunch of arithmetic. So n equals 1 in this first case, so 1 minus 1 would be 0. 1/3 to the 0, remember that's not 0, that's 1. Anything raised to the 0 is 1. And then 3 times 1 makes 3. And then we're just doing 1/3 to the 1 would be 1/3 of 3 makes 1. And then it's just, again, kind of grinding it out from there. I guess let me show one more step here where actually let me do it on this one. So if I have 1/3 to the 4th, what I'm thinking of that is I have a 3 up top, I have 3 to the 4th below, and I'm canceling. So that's giving me 1/27. So that's how I'm getting those exact fractions is by canceling. Next example, they gave us the first term is 12 and the common ratio is -1/5. Find the sixth term. Okay, great. So they told us a sub 1 is 12. They told us r is that -1/5 and that we are interested when n is 6. So there I am just putting in a 6 right there. To do this, so I did, this will be -1/5 raised to the 5th. So if we do a negative, if you put that in a calculator, it's going to give you a decimal, and I think they're looking for the exact answer, at least that's what I did here. So what I would have done to do that is a negative is going to the 5th is going to leave it negative, and then 12 times 1, that's just that 12 up there, and then 5 to the 5th gave me that 3125 right there, and so then just kind of cleaned it up. For number 10, write an explicit formula for the following geometric sequence. It starts at a sub 1, so we know a sub 1 is 3, and our ratio we can get by just saying 12 over 3, that would be 4. If I want to check it, 48 over 12, still 4. And then there's our first term, and then there's our ratio to the n minus 1. And just that easy for that one. And then this one is not that easy. So this one, write the first 4 terms of the geometric sequence starting at a sub 1, given these 2 terms. So this is kind of the geometric equivalent of the one that I did back here where we had to find the slope. So these ones where they give you 2 different terms and they're not a sub 1, that's kind of the version that is a bit of a bummer. So let me pop back down here. We're told that the 7th term is 81, and we're told that the 10th term is 2,187. So that's what I have to work with. What I did was I set up 2 equations. So you'll see I don't know why I did this one on this side and that one on that side, but I did. So here's when I put in a 10, I'm going to get out 2187. And I don't know the first term and I don't know the ratio because these are not successive terms, so I cannot find that ratio yet. On this side, same thing. When I put in 7, I get out 81. So there's the 81, and there's me putting in 7. And then right here, I would have reduced that to, that would be a 9. And then I solved both of these equations. So I have 2 equations, nonlinear system. And so I'm going to do a substitution with it. So I'm going to solve them both for the a sub 1 term, mostly because that seems easiest. And then what that will let me do is set them equal and solve. So on this side, I did 10 minus 1 made 9, and then I'm dividing over r to the 9th, and that got me this equation. Here, this would be r to the 6th, dividing that over, and that got me this equation. And now I'm taking, since these both equal the first term, I can set them equal to each other, and then that gives me a system I can solve with a single variable, because I've eliminated a sub 1. A number of steps you could do here. What I looked at, I said, I don't want to solve for 1 over r cubed. I want the biggest one on top because I don't want to solve for 1 over, I want to solve for the value itself. So I multiplied both sides by r to the 9th, and that brought that over here, and then I divided out this 81 on both sides. So what I was trying to do is get my variables on one side and my numbers to the other. So that got me to right there. I threw that in a calculator, I'm sure, and it came out 27. r to the ninth over r to the sixth, I canceled, and that got me r cubed, and then cube rooting both sides got me r. And then once I know my ratio was 3, I can come back to either of these equations. I bet I picked that one because it's easier. Yep. And so I had 81 over r to the sixth equals my first term, which is remember the two things I need to solve a geometric is the first term and the ratio, and right now I got the ratio. So back solving for the first term, I just put 3 to the sixth in there, and then I reduced, and then that came out 1/9. Whatever big number that had been, I would try going 81, dividing this by 81, and then just realizing it's going to be 1 over is a nice way of looking at it. And then once I got the ratio and the term, now I have my formula, and now I can just drop a 1 in there, 3 to the 0 would be 1/9. If I drop a 2 in there, I get 1/3, etc. And that lets me generate that list of the first 4 terms. So that wraps up 8.1.